we're now going to have a look at how we can actually use vectors. So far, vectors haven't really done anything very exciting. They have just been, well, we've just found out to do angles and lengths. It's like, what's the point of them? Okay, so we're going to start thinking about how we can use vectors to describe positions. Now, before we even read through any of this, I said that a vector was just a direction and a length, and it wasn't fixed anywhere in space. Do you remember I said that this vector was exactly the same as this vector? If they're the same length and direction, it doesn't matter where they are on the page, they are the same vector. When we change them into position vectors, this is where the rules change slightly, okay? Because they're describing something different. They're describing a position. Yeah, and someone said they're not coordinates. No, but we can use them a bit like coordinates if we do some of these things here. So I've said here, suppose that we started at the point, the coordinate, 3, 2, and we translated this by the vector 4, 0. Okay, we're moving it 4 along, and we're not moving it up or down. So where would the coordinate be if we moved it from 3, 2 and we moved it 4 to the right? 7, 2. The x coordinate would have increased by 4. So this might make us think that what we could do was we could take a coordinate and we could add on a vector to come up with another coordinate. But we're not allowed to do this. And the reason we're not allowed to do this is because this is a coordinate, and this is a vector, and this is a coordinate. It's kind of like dealing in different things at the same time. It makes sense that they need to be all in the same language. But only vectors can be added to other vectors. So if we treated the point 3, 2 as a vector, then this solves the problem. So we have 3, 2 plus 4, 0 is equal to 7, 2. What do you think 3, 2, if we change it to a vector, what do you think that's actually describing? How is 3, 2 as a vector linked to 3, 2 as a coordinate? Good. 3 to the right and 2 up, starting from where? From the origin. And that's what a coordinate is, actually. A coordinate does mean 3 to the right and 2 up. But it's saying relative to an origin. So when it becomes a position vector, we're describing its position relative to something else. Okay? We're saying relative to the origin, you go 3 to the right and 2 up. And then you go 4 to the right and nothing up or down. This means you will end up at the position 7, 2. The position 7, 2 is 7 right from the origin and 2 up from the origin. So it's the same, but it's got a subtle difference now when we're describing a position. It's no longer a vector floating around in space. It is describing where something lives on the coordinate page. So here, I've said that a vector is used to represent a position, is unsurprisingly known as a position vector. Here is that A, 3, 2. It has moved 3 to the right and 2 up. A position can be thought of as a translation from the origin as per this example above. It enables us to use positions in all sorts of vector and matrix calculations. Matrices are something that pops up in further maths, but if you go and do maths at university, you would also see how these can be used in matrices as well. So the position vector of a point A is the vector OA, where O is the origin. OA is usually just written as A. So if I'm saying the position vector of A, I'm actually saying start off at the origin of a graph, of a Cartesian plane, and follow that pattern of 3, 2, or whatever that instruction is, until you get to a particular point, and that will be the coordinate A. Okay? So let's have a look. I've got an example here, and it says the points A and B have coordinates 3, 4, and 12, 2, respectively. And you can see that on my graph that I've got down here. A is 3, 4 as the coordinate, and then B is 11, 2 as a coordinate. And the first thing it wants us to do is to find the position vector of A. So it's now not saying find the vector A, because it doesn't make any sense. It needs to be a position vector because we're talking about it on a grid. So for part A, the position vector A, also known as how you go from the origin to the A coordinate, is just going to be 3, 4, like this, which can also be written as 3i plus 4j. But I prefer the column vector. The reason I've done 3i plus 4j is because that's what it asked for. Okay, so write that down if you haven't written it down. And it's just nice to kind of see that in practice. A as a coordinate, we would have just drawn as a dot. But the position of A as a vector looks like this. That was the coordinate A. This is the position vector A. This down here is the origin. So it's still talking about the same thing, but do you notice there's a slight difference? When I think of a vector A, I'm thinking of the line from the origin to A. When I think of the coordinate, I just think of like a dot. And that's what I want your brains to start trying to think about, the subtleties of those differences that we've got there. And so B, it wants the position vector of B. Well, the position vector of B, we tend to just write it as B. And that means how do you go from the origin to B? And it's very simply just going to be 11 across and 2 up, which we could write as 11i plus 2j. And I'm also going to put that onto my graph here. And I'm going to draw in the position vector by saying I'm going from the origin all the way over here, B. And the direction is obviously going from O to B. And this is the vector B that I've got here. So can you just add those things onto your work? And then we're going to do a couple of problems. Okay, so what we'd like to do is actually, I mean, this is kind of obvious, right? There's nothing like mind-blowing yet. But part C of the question, we want to find out what the vector AB is, okay? We want to find out, how do I go from A to B? Well, if I want to go from here to here, going back to our first lesson on vectors, how would I actually do that pathway? I would go from A to O, and then I'd go from O to B. So I would go from A to O, and then I would go from O to B. I would go from A to O, and then from O to B. Yeah? But A to O is minus A. I'm going to just write it a slightly different way for a second. A to O is the same as minus O to A plus O to B. You don't have to, it's just to show you that if you go from A to O or O to A, they're the same thing but flipped. One's negative. And this is minus A, and this is plus B. So we get that AB is equal to B minus A. And this bit here that I've just written is very important and will need to be memorized. We're actually going to calculate it for this one in just a moment. But the way I remember this, for a position vector between two different positions, it's the second letter take away the first letter. It's the second letter take away the first letter. So you might like to just jot that down. Second letter minus the first letter. That's how I remember this. And you're going to be using this lots and lots and lots and lots. You don't want to always have to think what it is. You just want to look at it and be like, okay, it's this one minus this one. Yeah.
Is that always the case?
Always, always, always the case. Okay, if we're talking about position vectors, that is always the case. So let's actually just work it out here. The vector AB is B minus A. So I'm going to do column vectors. It's going to be 11, 2, minus 3, 4, which is 8 minus 2. Now let's go back to the diagram for a second. I'm going to draw this on in red. I'm going to go 8 across, 1, 2, 3, 4, 5, 6, 7, 8 across, and 2 down, and it does take me to B, which isn't surprising, okay?
So would you have to write 8i minus 2j?
If they asked for it in I and J form, you would say 8i minus 2j, but this is perfectly good. I like it just to stop here, okay? This is perfectly good. That's how I want to see that in your homework, okay? So this is the vector A, B. We went backwards along A and then forwards along B. The backwards along A is the fact that it's negative. The forward along B is this. Yes, Ismail.
Did you say about the second layer and the first layer?
So the way I remember this, to do AB, it's B minus A. So if I was going to do something like a different one, PQ, it would be the second letter, Q, minus the first letter, P. And if it was one CD, what would it be? D minus C, okay? So this is just like other versions of what this formula might look like, okay? It would be D minus C. And that's what I've written down in this box. It says for position vectors A and B, AB is OB minus OA that we had here, OB minus OA. But the thing I really want to remember is that AB is B minus A. It's the second letter minus the first letter. That is something that when you do a revision page or a flashcard for this topic, I want there to be something on unit vectors. I want there to be something on position vectors and how you find the position to two things. These are things that will make sense when you see it, but they need to go into your memory, and they go into your memory by you putting it into your memory. They don't just magically go in there, okay? So we're going to try and use this in a few pages now, okay, for just these examples, and then I think that's us going to be done, and that will take us up to the end. So it says the points A, B, and C have coordinates blah, 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 respectively, and O is the origin. Find in terms of I and J. I don't want to do it in terms of I and J. I'm going to change this. I want to do it as column vectors because I hate I and J. And any time in the exam, you could do column vectors, okay? It's just much nicer. I think in the textbook, they take up more space, so they like to write them going across. I think that's probably why they've done it, to try and save pages. And so we're going to try and find out the position vectors of A, B, and C, easy. Then we're going to find out the vector AB, the vector AC, and then some of these other things that we've got as well, okay? So for part A of the question, AI, we're going to find the position vectors of A, B, and C. Now remember, the position vector of A, we just write like this. And A is this one, which is 3 minus 1. So I'm just going to change it from a coordinate into a vector. I'm also going to change the coordinate of B into a vector, so it's just 4, 5. And I'm going to change the coordinate of C into a vector, so it's minus 2, 6, like this. So I've written now the position vectors of A, B, and C here and here and here. Remember that they are describing, what journey is this describing? What's it describing, where to where? From the origin to the coordinate A. Don't forget that's what a position vector means. From the origin to the position vector A. Now the second thing it wants us to do is to find out the vector AB. Ismail, what is AB equal to?
AB.
Yep, how am I going to say what that's equal to from what we just talked about?
E minus A.
Good, it's the second letter minus the first letter. So I'm now just going to substitute in with this information. I'm going to write this one down and I'll give you a chance to catch up and write it. So it is B minus A. So that is 4 minus 3, which is 1. Be careful, because it's 5 minus 1, which is actually 6. Okay, so I'll give you a chance to write that down, because I know I'm going quite fast. Not yet, because we're only doing this one. Okay, so I want you to have a think to yourself, what is the vector AC? How do you find AC? Zakia, how do you find AC? C minus A. So I'm just going to take the information I had previously. I'm going to do minus 2, 6, minus 3, minus 1, which is? Minus 5, 7. Minus 2 minus 3 is minus 5. 6 minus minus 1 is 7. Okay, now we're going to go on to part B of the question. I'll see if I can squeeze some of it in here. So part BI. It wants us to find in third form, what's this even asking for? What does this mean? From the origin to C, and it's asking for something else. The modulus, the magnitude of that. It's asking how long is that line. These things here mean how long it is. So we're going to do Pythagoras. And we're going to do Pythagoras to this one. This one here is OC, isn't it? Yeah. So I'm going to, for part B of the question, I'm going to say that OC the magnitude of that is just going to be equal to Pythagoras of this, which is just going to be what? 2 squared plus 6 squared, which is the square root of 40, or 2 root 10. Okay, don't use calculators. 2 root 10 for that one. Then I'm going to squeeze in here, I'm going to do BII. It wants us to do the magnitude, the length of the line between A and B. The length of the line between A and B, that's actually just, what is the length of, what is this actually saying, the magnitude of the vector AB? What's that actually measuring if you were to look at a coordinate grid? The length from A to B. It is telling you the distance AB. It's actually telling you this thing here, which is the distance AB. This looks really similar to a vector, but it doesn't have the arrow on the top. As soon as I take the arrow away from the top, I'm talking about a distance between two coordinates. It's quite confusing, the different language that's going on here. But this, the magnitude of the vector, is the distance between them. So I'm just going to do Pythagoras to AB. Which vector is AB? We've got it on the page somewhere.
It's 1, 6.
It's 1, 6. That's A, not AB. So we need to do it to 1, 6. So it's going to be 1 squared plus 6 squared, which is root 37. And then B triple I is the magnitude of AC, which is just the distance between A and C. So it's the magnitude of this one here, which is going to be 5 squared plus 7 squared. It's root 74. We're going to finish just in time. Let me just finish this and then I'll explain. Okay, so this time they've told us OA is equal to this and AB is equal to this. And we want to find out the position vector of B. So this is kind of weird. This is like they've given you some of the information and they're now wanting you to say, like, what was the original information, okay? So they've told me that OA is 5 minus 2. How do we sometimes write OA in a different way, though?
What do you mean?
How else could I write OA with the arrow on the top? The position vector of A.
Minus A O. No.
Just A. Just an A, like this. Yeah? Because this is telling you how do you get from the origin to A. And they've also told us that AB is equal to 3, 4. And we want to find out, what's the position vector of B?
You have to add them together?
Yeah, because I know that AB is B minus A. That's the formula that I've been using so far, okay? So if I want to find out what B is equal to, I'm going to add A to this side and I'm going to add A to this side. So AB plus A is equal to B, which means that B is equal to 3, 4, which is AB, plus A, which is 5 minus 2, which is 8, 2. Now, just before we move on, and hopefully before the bell goes, I'm just going to draw what this looked like as a diagram, because some people like formulae, some people like geometry, and I want you to see both ways that this works. So they told me what OA is. They gave me a position vector of A, which took me over here to A. And they also gave me a position vector, sorry, they gave me a vector between A and B. So I know what this vector is, and I know what this vector is. This here is the origin. And the one that the question wanted me to find is the position vector of B. So what is that going to look like on here? What is the position vector of B? From where to where? From O to B. And you'll remember at the beginning, this is the triangle law of addition. To go from O to B, well, the other way I could do that is I could go from O to A and then A to B, which is what we did. We went from O to A, and then we went from A to B. So this was using the formula. this was thinking about the geometry that would have said the position vector of B is A plus AB. So either of those ones would work. I'm very quickly just going to do part B of the question, but I say very quickly because I just want to find out what is the length of OB, which is just going to be this squared plus this squared square rooted. I could either write it the length of B like this, I could write it as the length of OB like this, but it's just going to be 8 squared plus 2 squared, which is root 68, which is 2 root 17. Okay? And then we're going to do some questions for homework, some of the stuff from the exercise we did in class, which was 11C, and then some stuff from 11D. Okay?